So here we're going to look at series and parallel circuits and their characteristics. Now what I'm going to do is record some experiments later on as well, which are real, so you can actually see these things happening over Easter. But the PowerPoint, here I've got some simulations. So we can connect up components in a circuit in series or parallel. Series I like to think of as like being a television series. You have to watch the programs one after the other, so the components are connected one after the other. If you don't watch your television series one after the other, you don't understand what's going on. Parallel is when they're connected next to each other. So series circuit has all of the wires in the same loop. Typical series circuit are the lights on Christmas trees. In the olden days, if one of these lights were to go out, all of them would go out. Parallel circuit has junctions. So for example, typical one here is the car headlights. If one of the headlights stops working, the other one carries on working. If it wasn't connected like this, one of the headlights were to break, the other one would break as well. You'd be in trouble because you wouldn't be able to see where you're going with the car. So if we're looking at series circuits, here I've got one cell. Turn on the circuit, bulb lights up. Add another cell. Add another bulb. There we go. Turn on the circuit, and both bulbs light up. But I want you to note down which is brighter, which is dimmer, and if I add 3 cells, even dimmer. If I can put an ammeters here, you'll see with 3 of them, I've got less current flowing. With 2 bulbs, I have a little bit more current. In 1 bulb, I have more current. But the current round the circuit is always the same in all places around the circuit. It's always the same amount of current flowing around the circuit. What happens if I look at potential difference or volts? Here I've got 2 volts, and so I've got 2 volts being given to the current, 2 volts being given away from the current by the bulb. Here I have 2 bulbs, so 2 volts being given to the current, and in the series circuit these bulbs are going to share the voltage, so they're going to give out 1 volt each. If I add a third bulb, we'll see that that is wrong. It should be 0.67 volts. So that animation, ignore that. That's 0.67 because that 2 volts get shared out between each of the voltmeters. So that is a mistake in the animation. If I add more cells, what's going to happen? 2 volts, one after the other. They're going to mean more push or more potential difference, so more current flows. If I have 3 cells, bulbs are going to get brighter because there's even more push. If I look at the ammeter, the more cells, the more push, the more current. Less cells, less current, and less current. But still, always current is the same all the way around the circuit. If we connect up the voltmeters, this is wrong. That should be 0.67. If I switch on this circuit, here I've got 4 volts, and if you add 1.33, 1.33, 1.33, we will get 4 volts. So this 4 volts is split between the 3 bulbs. And here we will get 1, 2, 3, we've got 6 volts, and 6 volts is split between each of the bulbs. So what when you're doing your Google Doc is to draw these circuits and write down observations of how much voltage, how much current there is, and also whether bulbs are brighter, dimmer, and then take a photo of all these drawings and pop them in the Google Doc for me. So in the series circuit we've got 1 pathway for the current to flow, so because current does not get used up, the number of electrons does not get used up, we've got the same current all the way around the circuit. 1 amp, 1 amp, 1 amp. So it's not the current that gets used up, it's the energy that gets used up. So in the series circuit, the voltage that we have supplied by the cell gets split between the two bulbs. So this voltage, 6 volts, will get split between each of the bulbs. Okay, the more bulbs we have, the more the voltage gets split, so the dimmer the bulbs are. In parallel circuits, here, same as before, I have 2 volts and I have 1 bulb. If I add another bulb to this circuit, I'll see I have the same brightness. And if I add ammeters in the circuit, you'll see I've got 0.6 amps coming through the cell, but at this junction here and here, this current splits to flow 0.3 through this bulb and 0.3 through this bulb. Then the current joins up again and becomes 0.6 as it comes back into the cell. So the current is split up. What happens to the voltage? Here I have 2 volts between here and here, and if you think, make the same connection here and here, before and after the bulb, I have the same connection as I will be connecting on each side of the cell. So in a parallel circuit, the voltage is the same across each of the components. It's the current that splits up, not the voltage. If I add another bulb, we'll see brightness is still the same, but now I have more current flowing through the cell. I've got the current splitting, 0.3 amps goes through each of the bulbs. If I put voltmeters in, those 2 volts from the cell, I've got 2 volts going through each of the bulbs. So what's going to happen if I add more cells? Here I've got 4 volts, so I'll have 4 volts through each of the bulbs, and the bulbs will be brighter. What's going to happen to the current? Here, what's going to happen is we're going to get more current because we've got more push. So 1.8 amps is flowing through the cells, and that's going to split into 0.6 amps through each of the bulbs. I add another cell, so more push, and I'm going to get more current flowing through the cells, and 0.9 amps going through each of the bulbs. And any guesses about what will happen with the voltage? I've got 6 volts here, so I've got 6 volts across each of the bulbs. So in a parallel circuit, the current divides at each junction. Whoops. So 2 amps here will divide into 1 amp through each of the bulbs, and then come back together to make 2 amps. But the potential difference stays the same. The energy between each side of the cell here is the same as the energy between each side of the bulb here and each side of this bulb here. So 6 volts here will be 6 volts across each bulb.